Yes, and hello and welcome to my next video in the 5170 IBM series. And we are going to continue where we left off last time. We are going to put things back together, and at least we are going to put the power supply back together to test if that works. I do have high hopes that this will work. I have very little experience with capacitor of that age actually breaking if they have not been tortured. And this computer, while it looks to have been used, is more rusty than it is dirty and well worn, I think. And these things are over engineered. They have capacitors and you are able to beat the hell out of that thing without it actually self-destructing as a modern power supply would do. And I do think that everything in there will last for 10 more years. I have absolutely, if it's not hot and if it's not overused and if it's not mishandled, then it will last. And these switch mode power supplies have a lower frequency. They didn't require the low ESR capacitors as new modern power supplies, and that also means that the capacitors has got less warm, so I do think it will be fine. And also that fan in there, it has no noise reduction and no speed reduction at all, so even though this is not reaching room temperature, it will just turn like hell and make a racket, and air will stream through this unit. So I'm going to put it back together, and I'm going to blow off some dust of these things, and maybe in this episode we will put the whole thing back together and check if it works. And the reason why I'm doing these things out in my shed is that you see that the bench behind me is not that I don't bother to clean it, but I'm in the middle of 3 or 4 projects there that require that space, and also this bench is way too small to handle anything like the case for the 5170. That is a huge beast, and I could have done this down in my cave, but I really don't like to be there in the summertime and make a lot of dust down there. I like to keep it very clean and nice. So if I have something dusty and rusty, the shed is the place. So let's just meet down at the shed, shall we? I'm going to put this back together, and I have to look into this Peak Tech. I not used it very much, but I do have to look into this and about measuring in circuit. And just going to remove this tape here. I'm covering this because I was only meant to spray where the rust was, so that it would be somewhat insulated and not spreading to other things. And I do have missed out a spot, and I'm not sure if it's because I missed it or because actually the acid that I was using made this rust afterwards, but I'm not going to do anything about it. And I'm just going to clean this out by blowing it with high pressured air from my compressor, so I'll be right back. Yeah, now it's much cleaner, and I've also done the pressurized air on the cabinet and some other stuff, and there is some signs that there are more rust on this than I initially thought, but it's probably been subjected to some moist environment. I know that I've kept it good and dry as long as that's been in my possession. Just let's take out these nuts that I put on these tabs. Yeah, how does this fit back together now then? This is the bottom bracket, and this is insulated from the bottom by this board, and it has one screw down here, so that's clear. And this one just has to slide in like so. And I have these ground wires here, and I don't know the reason why they have actually done 3 different earth taps on this. It's not a very good way of construction things, at least if you are going to maintain some good earth references with high frequency and switching stuff. I would think it would be better to just leave them in one point. This part of the case I have not painted, by the way, so it won't be affected, and the ground should be as good as it was originally. Yes, at least the switch is okay. And then it was this one. It was fastened by some screw at the back here. And it was also fastened with one screw here. Let's see what keeps this from sliding in place here. Might be some cable management. This one. Like so, that was the first one, and then it was the second layer, and this one was actually fastened by some hot glue in this side here. Ramps here, and it's supposed to be a little further back, yeah, like so, I think. This is also fastened by some of these screws, I seem to remember. Yeah, it's not totally straight in there, but this was the way it was fastened. And then it was this one on top, and that had these 2 plastic thingies here. And it has one plastic screw on this, one screw on this plastic standoff here. And I'm not sure what screw it was, but let's try with this one. Yeah, the cable managements look okay, and the switch here looks okay. And this should probably be with one of these screws. These old power supplies, that is the first or second generation of switch mode power supplies, they say that they can't start without a load, and that is correct, because to make these more efficient, they was never meant to operate without a load, because this is fixed to work in this computer and it will never draw zero current. So that's why they made it like this. And how much do you really need of a load? I'm not sure, but some people seems to draw them with hard drives and stuff. And I do think that the minimum load will be the motherboard. And that means that probably the most load should be of the 5 volt, because that's the case with the motherboard. So we just have to see when we are ready to test. But that means that it's difficult to get a dummy load that you can use. I can of course use a modern hard drive or stuff. Yeah, this is probably the wrong way. I do think this should be outside. Like so, maybe. This is a very old school grommet, but I like it as long as I get it to fit down here. It will be easier if I make this match the old grooves, I think. This modern thing is there are some special tools to use, but I can use one of my really old tools if that is to be. And this will not be completely fastened until I put this on top and get the other part of this fastened. But first I need to fix this fan blade. I'm now just finished mounting the power supply, and I did realize that I didn't blow the fan clean. Yes, but I can of course do that now afterwards. I'm just putting in some screws just to test to see if this actually works in some way or other before I do the complete rundown of this. Like that. Now it should be probably safe enough. Like so. And also I didn't blow off the lid here either. Yeah, I take that off afterwards. It seems like I'm being kind of sloppy here. And I did look up this hard drive, and you know what? It actually is a 30 megabyte MFM drive, so it's not a 20 drive that has been formatted like this. There is some strange peeping noise outside. But I do have seen others that has started these power supply just with spinning up some drives. And we can of course also connect power to this one. I don't think it will destroy anything. And as I said, I do think that this power supply works. So now I just have to find a cable. Yeah, that took a bit more time than I thought. Let's turn it off. And now it has power, and I turn it on. Yeah, I can hear the drive spinning up. And there it was upping this a notch. Oi, there are some I don't think this is all good. Let's measure the 5 and 12 volt. 5 on 16, that's okay. And 1173, that's also totally fine. And some of the other voltages, see if I can make this one. Probably problems with earth, but if I stick this like so, yeah, 11, 5, that's probably good. And we have the blue one, that should be the negative 12 volt. And I also have the white here, this should be negative 5 volt. So this power supply, it measures out totally fine. So I do think I will make. It's too late in the evening now to run the compressor. The neighbors would complain. So I have to wait until tomorrow before I blow the dust of this and fit it all back together. You can also hear that the hard drive now has, yeah, it's not spinning totally fine as I would expect it, but at least it's not totally dead. This drive does not appear to be working, but I'm not sure how it should react without the interface connected. So I'm going to continue this tomorrow. Yes, today it has been an extremely nice day outside, so I have not done much, but I did start up the compressor, and so this is totally clean now. And I also took the dust off the floppy drive, but you can see here these specks in the metal here, these small grooves are everywhere, and I need to see how well this drive head cleans up. I think I can see some green in there. Since we tested that this was okay last time, we can now put back all the screws. Like so, that should be the last of the screws. So I'm just going to put this back in. And as I said earlier, this is by no means a beauty contest. I do have some specks of rust here, but they are far beneath the main board, so I don't think it will be any trouble. And this should slide just in so. And then it's the screw to affix this. I wonder if it was these same screws like here. This is not often I get to use. This is very old. It's from 1993. I bought this back then, and this fits perfectly to these IBM screws. These for the front panel switches and lights, and this is the power LED, and this is the speaker, and the motherboard I did clean yesterday, so I will just slide this back in. See that this, yeah, now it should be right, and now this is down too like it should be, and this was fastened with just 2 screws. One on each side here. And these should, as always, be fitted with the black wires meeting in the middle. Yes, that's all the ground wires. And we can, of course, just, we did hear that this spun up last night, so I'm just placing it here. And I have the, you can see here, this is the Winchester, this is the floppy, and they have tried to do some keying on these. I can use some oxide cleaner on this connector down here. And then I use this board to This is not something you should try when it's on, but it will give a good scrubbing of the ports. This is the floppy cable, and this is the drive cable here, and it should fit like so, and this should go into the Winchester hole here. It's not very easy to make some good filming of this, but I'm just putting these contacts back together, and this was drive 0. And power, where was that? Okay, the power was way down there. Like so, and this earth wire was down here, and then it was the drive cable, data cable for drive. It's not keyed, but I do think it should be this way. Like so, and I can of course put back at least the VGA card, and this memory card thingy. I can put these switches back together first. I wonder if it was so that this is the hard drive light. Yes, it is, so this should be connected up here. Then it makes sense, and this is the speaker. Like so. Then it suddenly made sense. Yes, like so. I do have some VGA thingy monitor here, but it's not connected. So first I'm going just to try to turn this on and see if we can get some beeps. We do know that it will say that the floppy drive is not working, but I do think we have to do some more cleaning on this floppy drive. And I can even connect a keyboard. This is on the cheap side of AT keyboard. It's a Chicony, but it's fully working, nicely yellowed. No exploding tantalums so far. Yeah, I'm going to prepare for connecting a VGA monitor. It will be a bit awkward filming it, but I do think I will be able to get this connected. Yeah, I did find what I was looking for. I was searching for this, and this is an extension cable for 9-pin VGA. So now I just have to find an male VGA cable to hook up the screen. Yeah, at least no beeping and no other stuff, but I actually have to go, yeah, probably I have to go down to my bunker to get this VGA cable. Oh, it's it's making some sparks. The ground connection is probably not up to par. Yeah, the analog is in power saving mode, it says. I will actually try to boot this again and see if there is something on the screen. this is not booting into anything. The numlock and touch the keyboard is not powering up. So here we have to do some diagnosis, and yeah, I can't smell anything bad. I do have to check. I don't remember even if the AT does it require something special to boot up after you have changed the battery. I will have to check on that too, and I will get another VGA card. We can try also to boot by dropping the memory card. The switches is probably set for being used by this, but not switches, but the setup on the main board. But I'm taking this out, and this VGA card. Should be firmly seated. Yeah, we try again. Yeah, still no joy. So I'm going to detach this card too, so that we keep it simple when we do some fault finding on this. These are gold plated, so it should be no problem. But there was some tendency to a spark to the VGA card when I plugged that in, and there also was some rust there. So I'm going to connect this to the exact same outlet that I have the computer coupled up to. I'm going to connect the VGA monitor. Then I'm sure that there is no ground loops, at least. Yeah, but still no joy. Let's try again with that settled. I also have some corrosion on this VGA card. As I noticed earlier, you have this up here, but it should be making good enough contact. All the voltages are just fine. This CPU is actually running hot, so that makes me suspect that there is something wrong with this VGA card, and it could be, but then I have to go down to my bunker and check for my supply of VGA cards to see what we can actually get to work in here then. So the bunker it is, but that will be tomorrow. Yes, and here I have to break into this video with I've actually lost some footage, and I don't understand really how this went about, because I have been using my GoPro camera down in the shed and it has been working wonderfully, and the GoPro is very easy just to point and click on the record button. But in this case I did check that the recording started, but it has to have stopped somewhere. But there was plenty of battery and there was plenty of room in the GoPro. Maybe I've touched the button, maybe, I'm not sure. Maybe there is some timer issue, I don't know, because I was there about 20 minutes and I checked 3 different VGA cards. I have one Cirrus Logic, one other 9000 Trident and one 8009 Trident. And all of these cards I have tested before on AT systems with no problem at all. So I lost that footage. So the conclusion about that is this is not a VGA issue. It's a deeper issue with the 5170, and that means that we have to go the traditional way. It's not all about part swapping. In this case it was, because we already suspected it was a bad VGA card, and I know for a fact that some VGA cards don't work on the 5170. So with that conclusion away, we have to dig deeper into the 5170. And the next part here, I'm going to go through, just to get an overview of the schematics and what we have to deal with. So this is a bit more classic in-depth, but we're in this episode only browsing through what we do have of schematics and setups and stuff for this unit. So let's get cracking with that. Yes, and then we was back here again doing schematics. Strange how things turns out, but we are just going to do a quick walkthrough of this schematics now. And the schematics for the IBM XT and original PC are a bit better than this one, but there are some kind of detail here, but it's very splitted on a lots and lots of pages, but we will come to that in a minute. This is the basic block diagram of an AT, and it does not differ much in principle from an 8088 or 8086 computer. But we don't have the same multiplexing of the address and data lines. That's the main difference. But there is a lot of latching and buffering of the address lines. Anyway, so the count in chips and stuff is higher on an AT. And it's also using some more support chips that it has an extra DMA and interrupt controller. Otherwise, the principle is much the same. And of course you do have the added depth of the AT part of the expansion cards that has the extra address lines, the extra IRQs and the extra DMAs, and some extra control of memory read and write put out to these buses. But otherwise the 8-bit part here is the same as it used to be. And the AT has very rudimentary BIOS that is getting rid of a lot of the switches that is on an XT, and it's very basic what you can program. It's the type of floppy drive, type of hard drive, the real-time clock, and all this memory is, by the way, contained in the real-time clock. We will get back to that later. So it's basic information to tell the computer what is connected, how much memory, and so on. The layout of the board is what is called a baby AT. The original boards are this much wider, and this board contains 512 kilobytes, is able to take to 512K on the motherboard in 2 banks of 256K each. Our system is fully populated with the 256K chips, of course. And you also have this switch here that decides what display to use. But this is not in play when you are using EGA or VGA graphics, because this is monochrome and color for CGA generation of graphics. But the switch is there, and if I change to a monochrome or CGA card, this needs to be addressed. Yeah, otherwise there's not much to see here. We are going to see the parts in a bit more detail now when we start on the schematics. And here you have the main CPU. And you also have the MAT coprocessor that is optional, so we are not going to get into that one. And you have the 8284 chip, that is the clock chip that is generating the different clocks for the CPU and stuff. And it's also doing some basic reset that it keeps adding to the reset circuit if the power is not stable on the system. Otherwise, you do see that this has a full 16-bit data bus and 24-bit address bus. And you also have the special logic for the A20 gate to handle special cases of high memory and real mode and that kind of stuff. Actually, on the old ATs, I think this is controlled by the keyboard controller. Yeah, the 8288, that's the bus controller, yes it is. And it generates a lot of the signals that is used to control the memory bus. And also the control signals that is available on the AT extension bus. And you can also see that you have some memory buses, some buffering going on here. The data line 0 is becoming the shared data line 0 down here. And so with this data line, so this is for buffering the address line, the data lines. Here you have some PAL trickery, programmable error logic, and this is used for some trickery with some control signals for the busy and reset, if I don't remember wrong. And you also have the dividing circuit here with these flip-flops for the processor clock to the sys clock. And here you can see something strange with these schematics. The DMA clock is of course the DMA clock, but on the Q inverted here you should have the inverted DMA clock. That is the DMA clock with this line overhead. But on these schematics, all the inverse line is actually marked as minus. So you can see down here the P clock and the minus P clock. That's the inverted P clock. And the P clock is not the same as the processor clock, as this is this one up here. Yeah, a lot of buffering. This is the address buffering, the shared address bus and the latched address bus. And you do have some more trickery here with the RAS-CAS and memory refresh counters to make sure that the DRAM memory is refreshed. I do actually think that that is handled by some DMA and interrupts and timers on the AT. Yeah, you have some more data lines that is buffered here, and this is for memory refresh to make sure that they are not interfering with other buses and that refresh can happen when there are other data on the bus. It's just decoupled briefly. And this is this is something you don't see every day. This is actually a delay circuit. It's several different ways that you can make these delay circuits, but I'm not sure what kind of trickery is inside here, but you can make delays, of course, with flip-flops. You can make delays with... Yes, and then we was back here again doing schematic. And you can even make delays with inverter gates or buffer gates that is coupled in series to get the same signal out. It's adding the delay for each gate. Ticks. strange, but they are making sure that the signals for the address select lines here and the COS and RAS are in correct timing. I've actually never tried to measure on one of these circuits before. It can be interesting to put a scope on this and see what the signals look like. Yeah, and here we have the memory accessing circuit, multiplexing and demultiplexing of the COS and RAS. And the 8284 chip is the ISA clock generator circuit. And you can see here that is using some 14 point something crystal to make this happen. And also some dividing down here to 1.19 megahertz. And you also have some memory data for parity controller chips. That is the F280 chips. That is here. It's one for each bank of memory. And if this is not as it should be, it will report a memory parity error. Yeah, and the decoding of the ROM chips. You do have 2 empty ROM chips on the IBM for external ROMs. These are hard mapped, I think, to a fixed address. And same with the BIOS chips. And since this is a 16-bit data bus, you have 2 EPROMs, 8-bit EPROMs that are put side by side. So you have an even or odd or low or high part of the BIOS. Yeah, some trickery with clocks. Yeah, this is actually to make the ALE signals and other stuff on the XT part of the bus in the expansion cards. And also some memory trickery. Down here you have some control logic. Yeah, this is some intricate stuff. I'm not sure what's going on here, but this is buffering of the data bus into a new address bus. I mean the data bus, of course. And this is has something to do with master, so it's the DMA, acknowledge. I'm not totally sure. I have to dig into this if necessary. And the 8237 is the DMA controllers. You have 2 of them and 4 DMAs on each. This is memory decoding. This is a memory mapping logic IC, I think. And you do have some DMA and other stuff down here for control signals to the expansion bus. But this is to make use of some of the high address lines to make the 64-bit sliding window mapping work on the higher address bus. And you have the 8259s, that is the IRQ controllers, of course. And you do have some data also input here, because the timer circuits, the 8254 is also on the schematics. This is the timer circuit, so of course the speaker is timed on this and buffered to this 75477. We have gone into detail on this before when I did the Schneider PC, because this is about the same circuit. And yeah, nothing much here. These things has to work, of course. The IRQ is cascaded, so they are coupled together. So one interrupt, the highest most interrupt on the first controller is coupled to the lowest on the next controller. Yeah, and the 8042, this is actually the keyboard controller that stands on the motherboard. And this was the same until the complete chipset started to make this obsolete. They used some variant of this on all motherboards, and a lot of them are actually pin compatible, so that you can pull one from one system and put one in another. But these older systems do have some special peculiarities that is not always handled the same on newer systems, and that is among other things that you have the display switch connected to this. For CGA and other stuff it was necessary. That is used on one program pin here. And you also have the A20, the address line A20 handling is also done by this. So they did find some extra use for this. And the keyboard mapping on an AT is totally different from an XT. Also the protocol is slightly different. Yeah, this is the CMOS circuit. Here they have a CMOS hex inverter, and it's doing oscillator. You have here the 32 kilohertz crystal that is making the time of day clock tick. And you can see it goes in here into the oscillator on this chip. And this chip was the one that contained a very tiny amount of CMOS memory that was on the IBM AT. So this is the basic time of day clock circuit, and it's also coupled to the reset circuit to make sure that the time of day starts counting when the system is finished with the reset cycle that is happening up front. Yeah, and this is just the I/O connector pins for the AT bus. You have the new extensions and the old ones here, and here you do have some timings for and the DMA for the memory refresh circuit is done here. So everything of this is going to the memory refresh, I think. And this is the master reset circuit with timings to make sure that the CPU is kept locked down and every other circuit is locked down, and that the CPU actually starts when the clocks and other things are ready on the system. Yeah, and that was it for schematics. It's actually 21 pages with a very split up system. So the only connection we have between the systems is that you can see here it's linked to schematic 8, and this is linked to schematics 8, 11 and 19. So it's possible to reach back and forth and put things together, but it could have been easier, and also it would have been nice if they had some drawings what we would expect on some of these lines, because not everything here is self-explanatory. And you can also see here this is the minus reset instead of this reset, so it's a bit confusing at times. And this is the output of the power supply. And here you can see they actually stated a minimum load for each circuit here. But this can't be true, because I was running this power supply just fine with just the hard drive and the floppy drive connected, and they are by no way pulling 7 amps out of the 5 volt DC. At that time we was pulling maybe 2.5-3 amps of the 3 amps tops of the 5 volt, and it was still starting. But you can see it can supply 19, almost 20 amps of 5 volt. That's a lot, and it can supply 7.3 amps of 12 volt, but 12 volt is to spin up the hard drives and the other stuff, and it's the usual 0.3 amps on the minus voltage rails that is used for, the minus 5 volt was so little used that it was taken away on some things and only bothered the MediaVision users and some other sound cards and some special stuff. But the minus 12 volt is there for providing the negative part of an RS-232 signal that was part of every computer when the mice was connected to the serial port, and every user had at least a modem that was connected to the serial port. Yes, we are not going into more detail in this episode. This episode has gotten long enough, I think. So I will cut it off here. Next time I will take out the board and we will do some basic fault finding on the AT board on my bench. Yes, that was how far we got in this episode, and I'm back now to doing some explanation of what I'm doing, and that is my normal way of making videos when I get into a technical problem like now. I did have to fresh up on the schematics for the AT. I don't do just pulling chips and other stuff when I do fault finding. I have to understand what's going on, and at least this walkthrough of the schematics has refreshed my knowledge of this AT architecture, and I will probably know more about what I'm doing when we start the fault finding, and that we will do next time. I will rip out the card again so that I can do something behind me on the bench. I think it's much easier just to make sure that the system is booting as it should. And I might also try out some of the various diagnostic BIOSes that is available for the 5170 computer. I have never tried that kind of things on an AT computer before. I have used the diagnostic cards and stuff, but the AT is not doing diagnostic codes, at least not in the normal manner. So that's something we will probably look into. I'm eager to use some of my EPROMs. I actually done some cleaning and tidying up during the summer, and I found another box of EPROMs. I think it's about 3 kilos or something, just with EPROMs. So I have plenty. So I'm quite eager to use some of them. But enough talking. I might do some other episodes in between, but the next time we are revisiting the AT, it will be about what I said now, but there might be some other videos in between. So until next time, take care, and do look into some of my older videos if you're interested in this kind of topic. See you in the next one. Thanks for watching.